want you to take a couple minutes and think about these. I want you to translate these, so from words to algebra, translate them, and then find a way that they are alike or similar, and then find a way they are different. And you can talk to your table partners about why they're alike and different. You can talk to them about how you translated, how they translated. You can write on the desk if you want, grab markers, you can grab paper, whatever you want to do that. So I'll give you a couple minutes to translate both and figure out a reason why they're alike and translate these two. Anyone want to tell me the answer, how they translated the first one? So the sum of a number, we're calling that x, and 8, so we're adding those together, all squared, so these should be in parentheses, squared outside, less 5, yes. Anyone translate the first one? Even if it's wrong or you don't think it's right, still give it to me. So twice the quantity, that just means 2 times whatever comes next. A number, we're calling it x, less than 5, so 5 has to go after that, increased by 8. So these are the correct translations. Now let's talk about how are they similar? What did you find that was alike? They're both being increased. I'll just put plus under that. You don't have to write these down. You can if you want to. What's another way they are both alike? Okay. So very specific. So I'll put they both add and subtract, but then they both add 8 and subtract 5. In different orders, but they both do the same thing. Anything else in this? Okay. They both have parentheses. I saw another hand actually. Okay. So I'll go like this. The variable is inside the parentheses for both. Any other? We could have chosen 2 different variables, but in this case, both of Ashley and Isaiah had the same variable. Could be different, could be the same. What else? The numbers are the same. Even though this one's being squared and this one's being multiplied by 2, there's a 2 and a 5 and an 8 in both. I think someone in first or second said, go ahead. Okay, we can say that. One is in a different position than the other, but yes, there is technically a number outside of both. So this kind of goes with what someone in the other class said. They're both multiplying in a different way. So this one is a clear multiplication, it's multiplying by 2. This one is multiplying by itself. It's still multiplying, but you could say they're both still multiplying. All right, let's find some differences. What is different between the 2?
One of the equations you have is squared.
Okay. Difference. One is being squared. I don't know squared versus multiply. Were there any other differences you saw? So here we said that they're both adding and subtracting, and adding 8 and subtracting 5, but the order in which they do that is different. So here they subtract 5 and then add 8, and here they add 5 and then subtract 5. Anything else? Wording, the less than 5 and the less 5. They're both subtracting, but in a different way. Less 5 means exactly that, subtract 5. But less than 5 is that turnaround phrase. You have to put 5 in the end. Right? So this was just one type of warm-up that we'll do just to kind of get your brains thinking about math and what we did in the past. Now the next thing we're going to do is the notes, but before we touch the notes, there is something we need to talk about first. We'll do those math later. So you can either follow along with me on Canvas, doing this electronically, and I can show you where that is. If you have your computer, that's great. If you want an iPad to do that, that's also great. If you don't have those things or want to get that out, I also have actual algebra files that you can use and play with on your, not play with, but use and rearrange on your desk. Does anyone want actual algebra files? Okay. iPads, give me 1 second. Anyone else? Okay. And these. So those of you following along, you're going to go into Canvas, go into my course, and you're going to go into electronic algebra tiles. The things I do will not be the exact same things you do, but you'll have a chance to still play with and figure this out as well. Everyone with actual algebra tiles. I'm going to be talking about these electronically, but you're going to be doing this on your desk. So those of you that go into electronic algebra tiles, you should see a screen that looks like this. You're going to go into using algebra tiles, and then match expression. Right? So our end goal is to simplify expressions. But before we get there, we're going to model expressions with algebra tiles. Some of you may remember that. Some of you may have not ever done that before. So we're going to talk about what these things are, what they mean. Right? Those of you doing this electronically will be able to see this. Those of you with actual algebra tiles, I'll explain what these pieces are. You have not seen them before. The smallest square, find that. There are two sides to it. one is beige or yellow. That is your positive 1. The red side is your negative 1. So red is always going to be negative. Then find your rectangles. Those are going to be your x's. The green side is your positive x. The red side is your negative x. And then find the big squares. Those are your x squares. The blue side is the positive x squared. The red side is the negative x squared. Okay. Before we start, everyone electronically find this link. Alright, so we are going to model 3x. How do we think we would model, using these tiles, 3x? And I should do this over here because it doesn't like, the smartboard doesn't like this application. What do you think? It could be a guess. We can see if it'll be right or not. This kind of only works if you guys participate. Otherwise, I'll just be sitting here all day waiting for an answer. What do we think? Which of these?
3 of the positive 1.
You're saying these. So if you're doing this electronically, if you press this times 3, it's one of those. Yeah, okay. It will multiply it times 3. And then, Zachy, what was your thought process after that?
The X.
Okay. So notice how these two things are different. This is saying x plus 3, but we want 3x. So we have to fix this so that we have 3x. So let's restart.
With 3X.
3 positive green x's. So if you're doing this with your algebra tiles, you should have out your rectangles and be putting 3 positive x's. And that would be the equivalent of 3x. So Jackie, I'm glad you did that because a lot of students confuse the 3x as 3 and then an x, but in this case we want actual x's to represent this. Great. Questions about that before we go on to the next one? Great. So now we have 6x. 6 positive x's. Let's do this times 3. So then you would have 6 positive rectangles or the green x's lined up to show that that is 6x. Okay, let's do another. I'm going to actually skip past this one because we kind of just did a bunch of x's. I want something different. Right, -5, how would we model that? Go ahead, Ashley. 5, -1, so the smallest square, but 5 of them. So you would get out 5 of your smallest squares, make sure they're all on red, because if you have any positives, that would be different. Alright, what about 3x squared? How would we model that? Go ahead, Lily.
3 of the positive x squared.
Yes. I don't know if I have that on. Yes. 3 of the positive x squared. So just like when we were doing the x's, you can't do like 3 ones and an x squared. You have to do 3 of whatever it is. Let's move on. We kind of just explained this, so I'm going to do this one. Great. Now here's something a little bit more complex. Now we're doing 2 things, -2x squared and 3x. Someone tell me just one piece of that. How would we do that? All right.
2 to negative x.
Okay, so 2 of these. And then the 3x, how would we model that part? Ashley?
3 x's.
3 positive green x's. So when you model this, you should have 2 negative squares and then 3 positive x's. If at this point you want algebra tiles, does anyone want regular actual algebra tiles and have changed their mind? Okay, just want to make sure. Alright, this one, negative 4x plus 4, how would we model that? Tell me one piece. Ashley. 4 of the negative x's. And then we need positive 4. Vanessa. 4 of the positive ones. Right, so you would have 4 negative x's and then 4 positive ones, and that would be our negative 4x plus 4. Let's try again. 3x squared plus 4. Ashley?
3x squared.
3 positive x squareds, and then the positive 4. Vanessa? Positive 4 ones. Okay, let's go on to a little bit harder. So now we have all 3 things. X squared and x's and the constants. Tell me just one of those things. Vanessa? This one? Okay. Oh, I forgot. I'm on times 3. Alright. One of the other ones. Ashley?
5 negative x's.
5 negative x's. And then positive 3. Sandra? 3 positive ones. Right? And notice that they're putting it in that order that we talked about. Maybe not. What is that thing called in English? When it's something, foresight? Something like that, yeah. Right, let's do a couple more of these and then go on to something else. How would we model each part of this? Hello? Blue positive x squared. Just one of them though, not 3. Isaiah?
3 positive x.
3 positive x's. And Anessa? 2 negative ones. Alright, last one. 5x squared minus 3x minus 4. So before you answer, I want you to model it. If you have actual tiles, if you don't, be thinking about what it would actually be modeled like. And then someone tell me, how would we model those? Alright. 5 of the positive x squareds.
3 negative x.
Okay. Try again. And then we need negative 4, Nessa. 4 negative 1s. Congrats. Alright. Now I'm going to go into 0 pairs. So if you're doing this electronically, you can also go into 0 pairs. And I'm going to talk about what this is before we do it. So 0 pairs are like your additive inverse. So if you have a positive and a negative, they come together to make a 0. You can add or subtract them together to make a 0. So when we talk about 0 pairs, we want to put in positives or negatives depending on what's already there. So in this case, we would be adding in negatives, putting in negatives, so that we create 0 pairs, so that that pair over there becomes like a 0. Alright, so we have 5 here. Our goal is 2. So how many negatives will we put in to get 2?
3 negative 1.
Correct. So if you're doing this online, you'll need to line them up somehow so that they disappear. But the actual algebra tiles, you would put out the 5 that were there, 5 positive ones. Then you would put out 3 negative ones, and you would pair them together. And then those pairs you would kind of put off to the side. That would show that they're trashed or they become 0. All right, so let's try again. All right, we have 3 x's. We want to get down to 1 x. How many negatives will we put in? 2. So if I put in 2 negative x's, here we go. They would both disappear, leaving just 1. So again, with the actual alpha tiles, you would have 3 positives, 2 negatives, and those 2 negatives would count as the trash pile. All right, one more time. I really want an x squared, so I'm going to skip through some of this. There we go. Right, we have 6x squared, we need 5x squared. How many negatives would we put up there? How many 0 pairs would we make?
1.
Just 1. Right, and it tells you like what we're doing, the 6x squared minus 1, and then we cancel out that 1. Alright, so now that we have a gist of how to model and what 0 pairs are, now let's talk about our actual nodes. So let's start with this first one. Start with this first one. Okay. So I'm going to be modeling as you are. So you no longer need the electronic because we can't use that for this. If you want an actual set, I can grab that for you. If you don't want it, you're going to be drawing in your own squares. Does anyone want an actual set? I'll do that in 1 second. I think that's okay. Let's see. You know where the closest bathroom is. Make sure you put it later. Okay. These are my algebra tiles that I'm pulling from, so ignore those. We're going to model each piece and then simplify, make 0 pairs. So how would I model 1x? These are the same as before. These are your x's, positive, negative. These are your 1s, positive, negative. We do not have x squared up here. How would I model positive 1x? The green positive x. So get that out. And then positive 1, how would we model that? 1 positive in yellow or beige. And then 2 negative x's, how would we model that?
2 negative.
2 negative x's, the rectangles. Okay. So once you have that model, you're looking for zero pairs. Anytime you see a positive and a negative, you want to group those together and kind of put them off to the side. That's your trash pile. They disappear. They became zero. So do we have a positive and negative zero pair? Yes. The X's. So I'm going to move those off to the side so that is my trash pile and look at just what is left. So, yes, it is X, but is it positive or negative? Negative X plus 1 or negative 1X plus 1 would be the final answer for that. So make sure you write that down on that example. Do we have any questions so far on how we modeled that, how we found the zero pairs, got rid of them, found the final answer? In case you won't be able to use electronics, you'll have to go on your algebra unless you want to use it. Let's go on to Alright, so again, we are modeling negative 2x. How would we model that? How would we model 3x? Positive 3x. 3 positives. 3 positive x's, your rectangles. And then negative 2. These are the yellow ones. Or the red ones, because they're negative. And then negative 1. 1 negative, which one? The square, the red. Right, and then do we have zero pairs? Positives and negatives of the same type? Yes. How many zero pairs do we have? 2. You're going to get rid of 2. 2 pairs of greens and reds, and then you're going to count what's left. What would be left? I heard X and minus 3. So X minus 3 or 1X minus 3, either or does not matter. Just make sure you have that answer written down. Questions so far? How we modeled, found the zero pairs, simplified to find the answer. Let's skip this one and then move on to this one, the very last one. If you started the next one, that's fine. Alright, so now we have x squared. Now we're going to model each one. So I want you to take a second and model each thing. So your model should look like mine. 2 positive x's, 3 positive ones, 3 negative x squared, 2 positive, 2 negative ones, 1 positive x squared, 1 negative x. And then you're going to find your 0 pairs for everything. Your x squares, your x's, your 1s. Find those 0 pairs and go ahead and move those off to the side and see what's left. You go ahead and do that. I'll give you a second to do that. Everyone get the same answer I did? Anyone not get that answer? What's left? So I'm rearranging how you said it because we have to have it in a specific order. Always highest exponent first, and then to lowest exponent. If you don't have any exponents, then variables, and then if you don't have any variables, constant. So it's always going to be in that order. Highest exponent, variables, constant. So now I'm going to show you how to do, I think, those same problems or similar problems, but algebraically. And then you can choose. If you like the algebraic method and don't want to use the algebra tiles, that's fine. If you still want the algebra tiles or like using the algebra tiles, you can continue to use them. So on to the next page. When we do this without the algebra tiles, we want to find, so like the other day, the last week when we were grouping terms together, we were sorting them into like terms. We're going to do the same thing. Find like terms. Terms that have a variable but have the same variable, and I'm going to box these in to show me that these two are like terms. And then I'm going to do the same thing with these constants to show that these do not have a variable. These both don't have variables, and they can be combined. They are like terms. And then we're going to take the numbers in front for the x's. So negative 2 plus 3. We'll worry about the x here in a second. What would that be? And then after you find that, you would just put x behind it. Then you'll do negative 2 minus 1. Figure out what that would be. Negative 3. And then you would rewrite those two together. So you can write it as 1x. Eventually, you want to get away from writing the 1. Just know it's invisible and that it's there. Either of these answers are acceptable right now, though. Do we have any questions on how we found the like terms, combine them, and then simplify to get the right final answer? Let's try another one. Does anyone so same thing. What are our like terms here? X is one of them. Isaiah, give me another.
-4 and 2.
Okay, so this is a separate set of like terms. Any other like terms with just x? Negative x. Anything else? Negative x. So all of the x's go together. Right? So then you're going to do the same thing. Remember that there are ones in front of these. We're going to do 1 minus 2 minus 1. You can do that all at the same time in your calculator, or you can do 1 minus 2 and then minus 1, or you can do negative 2 minus 1 and then go back and do 1 minus. Doesn't matter. Subtract that, so what did you get? Negative 2. And then when we combine our negative 4 and 2, we get -2. So this answer should look familiar because that's what we got when we did it with algebra tiles. It is really the same problem. We're just now doing it algebraically. Questions on how we combine like terms? Sorry, simplified. Got that answer. I want you to try this last one. So be careful here. The x's can't go with the exponents like we talked about last week. So find those like terms, group them together, and then combine them. Anyone want to share their answer? Plus positive 2x or negative? So we did just get that answer. It should be the same. Negative 2x squared plus x plus 1. And when you combine the x squares, you're doing the same thing you did for the x's. Just combining the number in front and then putting x squared after it. We're not actually squaring anything except the x. Okay. Questions on that before you continue? Really quickly, stand up, stretch, shake your legs. Shake some movement into your arms, your legs. next page. And on this page, I want you to find any questions that look complex, complicated, you're not sure where to start, you have a question about it, anything like that, and we'll go through those. I will say if you choose 5 and 7, we're only going to do one of those. So you choose on. Any that look complex, any you want to do together, you have questions on that. 7. So that means you won't do 5, you'll end up doing 5. Any others? Okay. Any others? Alright, let's start with 6, and then we'll do 7, and then if we have any others, we'll go back and do those. Right? So this is really the same thing that we were just doing. It does not have decimals and fractions. So if you want to use the algebra tiles, you cannot use them on ones with decimals and fractions. Anything else is usually fair game, except for like this one we can't use it on because there's 2 different variables. Great, so you would do the same thing. Look for like terms. So terms with the same variable. And then terms without variables. And you would do that same process as before. Whatever it says, 0.25k minus, this is really 1k. I didn't mean to use pages, sorry. Subtract that. How much you get? Bless you. Bless you. 25 minus 1, what would that give us? Negative 0.75. Then you would put k at the end of that. And then you would do the same thing for 1.5 minus 3.5. It helps when you box in whatever the symbol is before, that way you see whether you're adding or subtracting. What would that give us? Negative 2. So then we would rewrite this as negative 0.75k minus 2. That would be your final answer. Questions on that one? So 7, we're going to do the same thing. It has fractions. We're going to leave them as fractions just because it's the 1/3. If we made that into a decimal, it'd have repeating decimals. We don't want to deal with that. So process is the same. We're looking for like terms. So the things with the same variable are like terms. And then the things without are also like terms. Right, so we're going to combine these fractions by hand, and then I'm going to show you how to do it in your calculator so you can double check. So let's say we started with the cube. In order to add fractions or subtract fractions together, they have to have the same denominator. In this case, they do. So we're just going to add the numerators and keep the denominator. What would that be? 4 to 6. And then anytime we can simplify or reduce it, we want to do that. So these can both be divided by 2, so this will be 2/3. Okay, then we're going to do the same thing with 11/12 minus 1/3. These do not have the same denominator, so we have to change the 3 to 12 by multiplying it by something. And then what we do to one piece, we have to do to the other of the fraction. So 11/12 stays the same, but this becomes 4/12. Now they have the same denominator, subtract across just the numerator, the denominator stays the same. What would that fraction be? 7/12. So then our final answer, 2/3 cubed plus 7/12. Right? At this point, if you do not have your calculator, go grab that because you'll need it for this part. And then before we do anything, I want you to hit these buttons. Second is blue in the corner, plus, and then the number 712. So whatever I press up here will be down here. If you missed what I said, you can always look back up there. But second in the corner is blue, plus 712. That will reset the whole calculator. Everyone uses the calculators, so you may not need their math. It may confuse your math calculator, whatever. Just always reset it. And then you're going to go into alpha, the green button, y equals at the top, and you're going to get a menu that looks like this. And you're going to go into the first one, so you can press 1 or you can press enter, either or, doesn't matter. But you should get a fraction bar that looks like this. And you will not get that fraction bar. To get the fraction bar, alpha y equals, and then 1 or enter. Then we're going to put in the fractions that we had. So let's do -1/6 plus 5/6. You're going to use this button at the bottom for negative, so the one right next to enter. Not the minus. You'll get an error if you use the minus. 2. You can scroll down to put in the next number, but then you have to scroll to the right to get out of the fraction. Otherwise, you'll be putting in numbers inside the fraction and all that. That's not the number I'm going to put either. I'm going to put -1/6. You should try that. So I just use my arrows to go back and just retype over them. And then I'm going to add in plus and then add in another fraction, alpha y equals, and then 5/6. And then enter. And it's always going to give you the most simplified version of that fraction. So use your calculator to double check your work always. It's always a good idea. Questions on how to put those in the calculator? You need to do it again. So I'll do it for the other one. 11/12 minus 1/3. Okay, so alpha y equals, alpha green, y equals at the top, 1 or enter. And then 11, scroll down, put in 12. Scroll to the right, and hit minus, not negative, because we're actually subtracting. And then do it again, alpha y equals, and put in 1/3. questions on this page before I let you try one? I want you to try number 5. Simplify that answer, and then we'll come back and we'll talk about it. Anyone want to share their answer? Ashley?
6
Did everyone get this answer? Anyone not get this answer? Anyone seeing if you do it? Okay, so for the p's, we have negative 2/3 plus 5/6. We have to get these to be the same, so we have to multiply the 3 by 2. And then the numerator by 2 as well. So this would become negative 4/6 plus 5/6, which would give us 1/6. And then p. And then for the 1/5 minus 1, all whole numbers are already over 1. You can rewrite it as a fraction. There's an invisible 1 under every single number that you know. And then if we want these denominators to be the same, we're going to multiply this by 5 and this by 5. So that the denominators are the same. And then subtract across. 1 minus 5 will give us negative 4. 5 is the same. We're just going to do a few-ish more problems in this, and then we'll be done for today. So go on to the next page and find this equation. Now, I am going to show this algebraically. However, if you would like to try to use the algebra tiles here, we can do that as well. Would anyone like to see how this is done with algebra tiles? Okay. So I'll do that. You don't have to do it with algebra tiles. I'll do the algebraic version in a minute. If you no longer need or want to use your algebra tiles, you can put them back in your bag and put them up here. So you would model this exactly how it looks. You would take what's on the inside, x plus 2, 1x, and then positive 2. What's on the inside? 1x and then positive 2. But because there is a 3 on the outside, you're going to take that and do it again and do it again. So that there are 3 sets of this. So you would end up with the same thing 3 times. And then you would count if there's any 0 pairs, you would get rid of that. If there's not, you would just count what is in this, and that would be your answer. 3x plus 6. Now, for those of us that put our algebra tiles away or / wanted to do this algebraically, this is how we would do that. We are distributing, multiplying the 3 on the outside to everything on the inside, to the numbers, not the variables. So we would be multiplying 3 and 1 to get 3, put the x behind it, and then we'd be multiplying 3 and 2 to get 6. And then we would just put those in order. 3x plus 6. Questions on how to multiply the number to everything inside and rewrite it? Alright, let's do another. Vanessa, did you want this one done in algebra? Alright, let's do this one algebraically. Multiply the 2 to everything here. we have 2 times -1, which would give us -2, and then for x, and then 2 times 1 would be a +2, and then you would just rewrite. Questions on that? We're going to skip the next page. Some of you started that page, and that's fine. We're going to go on to this one. Anyone want to see this one done with algebra tiles? No? Okay. So with this one, you can do this algebraically 2 different ways. So I'm going to show you both. One is using your order of operations, grouping or parentheses first, so doing what's inside the parentheses, combining your like terms. So if we combine these like terms, -2x, I'm sorry, I gave you an answer. But -x minus x is what? And then 3 plus 2 is what? So you would combine your like terms and then distribute the 2 to everything here. So 2 times -2 would give us 4x, and then 2 times 5. Now we're going to do this again, but a little different. So let's say I forgot about order of operations, and I'm just thinking there's parentheses. I have to distribute. I'm going to rewrite it. So if I forgot about the order of operations and I just started distributing, and I would need to distribute to every single thing in this. So we'd be multiplying to get -2x plus 6 minus 2x plus 4. But then we would, still have to combine our letters. And when we combine those, we would get 1. The exact same thing, just done a different way. So in this, whether you distribute and then combine like terms or combine like terms and then distribute does not matter. Now when we get to evaluating, that will matter. But right now it does not. As long as you're doing both steps. Do we have any questions so far? Alright, we're going to do the same one on that same page. I'm sorry, the next one on that same page. Right? Distribute the 3 to everything on the inside. So what would this become? 3 times -2x, and then 3 times -1, -3. Then we're just going to bring down that plus 4x at the end. What would be our next step? So the -6x and the 4x get negative. Questions about how to distribute and combine like terms so far? It's making sense so far? Yes. On to the next one. Harder examples. Now it says do it with algebra tiles and algebraically. If you want the algebra tiles, you can use them. If not, you can use it. Just do it algebraically, that's fine. Right? So there are two sets of distributing, yes. We're going to do them both at the same time. So then what would this first piece be? 4x plus 1. Then we're going to bring down that negative 3x. What would the last part be? So the pages aren't numbered, but they're like the more complicated examples towards the end. Alright, what is our next step? Vanessa. Combine like terms. So figure out what are the like terms here. We have 4x, negative 3x, negative 2x, and then positive 6 and positive 8. Go ahead and combine those. And tell me what you got. Negative x plus 14 or negative 1x plus 14. Either or right now. Do you have any questions on how we got that? We're going to do one more for today and then be done. Try this last one. I'll give you a minute or two to do that. The answer up here, but if we need to see it done, I will do that as well. How many of us got that answer? Negative x plus 1. I saw a lot of us. Good, good. Does anyone need to see that done? You can't find our mistake and you didn't get that? Okay. So we would be distributing twice. So this would give us negative 6x plus 2. This would give us plus 6x minus 3. And then we would just bring down that negative x plus 2. There's a lot. Then combine our like terms. When we combine our x's, the negative 6x and the 6x, that's at 0 pairs. Those are going to cancel each other out. Just leaving negative x. And then we have 2 minus 3 gives us negative 1. Negative 1 plus 2 gives us positive 1. Alright, so in a moment, I'm going to let you put your calculators back, grab your phones. Before I do that, if you did not do the Delta Math that was due on Friday, so the one on translating expressions, I'll be calling you up just to make sure that you remember that so that you could do it, because you could do it before class ends. Also, there is one due on Thursday on simplifying expressions. Some of you started working on that, some of you haven't. Make sure you do that.